Chapter 6, Special Review. These special reviews only show up at the end of the unit. And so this is the, or part, I think is what they call them. So this is the end of parts 1 and 2. Okay, number 10. Nope, number 6. Among entering students at a certain college, the men averaged 650 on the math SAT and their SD was 125. The women averaged 600 but had the same SD of 125. There were 500 men in the class and 500 women. For the men and the women together, the average math SAT score was... How do we know it's 625? We don't even have the measurements. It's right in the middle. Why? How come I'm allowed to take the average of the men and the average of the women? Because you can't always do that. They have the same number of people. Right. So, and this is a really important idea, so I'm going to spend some time on it. So, the women averaged 600, and there were 500 of those women. There were also 500 men, and they averaged 650. Okay? Now, without looking at the SD, I have no idea what the spread is. So let's not do SD yet. But let's just look at the total number of points scored by the women. And maybe we'll simplify this down for a minute. Let's say I give everybody a handful of, not jelly beans, something better. Reese's Pieces. Yeah. I showed E.T. to my kids recently. Good show. So, I give you all a handful of Reese's Pieces. Okay? And you count them up, and you tell me what the average is. I have no idea what Dalton has in his pocket. But I know that if you redistribute all the M&Ms evenly, then everybody gets the average, which we'll say is 20. Okay? So if you know how many people there are and what the average is, can you calculate how many Reese's Pieces there are? Yes, it would be the number of people. So let's say there are 20 people in the class. 20 Reese's Pieces. There are 400 total. Do I know how many Caitlin had to begin with? No, but I know how many there were total. So I can figure out the total points for women. What would it be? 500 times 600, which is 30 and then 4 zeros. So the women had a total of 300,000 points scored on the math SAT. What about the men? Well, it would be, I don't know what that is, 500 times 650. So that's 325,000. So total points for men is 325,000. Okay, add those together. 625,000. How do I find the average? Divide this by 1,000. And I get 625. Okay, now, why am I allowed to take the average there and equal that? Because there are just as many men as there are women. What if that's not the case? So let's say there were actually 600 men. Well, that changes this number. So now 600 times 650. Now that's 390. So I take 300,000 and I add to that plus 390,000, and I get that, and I divide it by 1,100 because my new total is 1,100. So divide that by 1,100, and how is this number going to compare to 625? It's going to be larger. Why? We increased the higher scores. and I get 627. Okay? Is there an easier way to do that? Let's try the averages. So 600 averaged with 650 still gives me 625, which is wrong. Now, some teachers have weighted grades on Aspire, like me, and some teachers don't. And every year somebody gets upset because they'll go down to total points on their report card and they will say this number divided by this number is higher than my actual grade. And then I try to explain to them it's weighted, so test points are worth more than assignment points, and they don't understand. But here's what you can do. What is the percentage of women? 500 of the 1,100 people are women, which is 45%, 45.45%. What's the percentage of men? Well, it's going to be the opposite of that, which is 54.54%. Okay? One thing you can do is, you know that 45% of the average is 600. We also know that 54% of the average is 650. So I'm just going to take 0.4545 times 600, and that gives me a score of 227. And then 0.5454 times 650, and then I just add those two together. And I should get 627. Okay? Most people don't know you can do that. And some of you probably don't understand that, and that's okay. But this is how weighted averages work. It's important to know if this number and this number are the same, then you can just take the average of the averages. But what are the chances that that's going to happen? Very slim, unless you purposefully stop at 500. Okay? So if you want to take the average of the averages, and there are different denominators in each average, it's really easy. Just figure out what the percentage of the population is, add that to, or multiply that by that particular average, do that with all of the averages, and then add them together. Now, if you don't understand that, you can do it the long way, like this, but you don't have to. So the important thing to know in this question is, we are allowed to average these only because the samples were the same size. If they're not the same size, then it's more complicated. Okay, B. For men and women together, was the SD of the math scores less than 125, just about 125, or more than 125? Okay, I'm hearing all three answers. So the women look like this, with an average of 600. What does the men graph look like? Exact same shape. Why is it exactly the same shape? Because the SD is the same. So I'm going to take this exact same shape, and I'm going to move it to the right. So that number is 650. Now, if I combine all of those into one, what is the new graph going to look like? Shorter and wider. So now it's going to be shorter and wider, which changes the SD, makes it larger. Yep, which makes sense. Now, in this case, apparently the women didn't do as well on testing, but if you think about height, if we only measured men and we only measured women, they would probably have about the same SD. But when you combine men and women together, that SD is going to be larger. because you have more variability, right? There are more taller men and there are more shorter women usually, and so that would stretch the SD. The graph would be less tall and wider. Okay, number 8. Table 1 on 99 reported 100 measurements of NB10. The top panel in figure 2 shows the histogram. The average was 405 with an SD of 6. If you use the normal approximation to estimate how many of the measurements were in the range 400 to 406, would your answer be too low, too high, or about right? Okay, so we're looking at the top panel in 102. So go back to 102. What's wrong with using the normal curve on the top panel of 102? The outliers wrecked the normal curve. What did the outliers do to the SD? Made it larger. So if we did 400 to 406 in the top panel, would we capture too many scores, the right amount, or not enough? We would capture too many scores. Wait, let me see how they worded that. Is it worded the opposite way? I was afraid of that. So if you use the normal approximation, would your answer be too high, too low, or about right? It would be too high. We would capture too many scores. Okay, so here we go. So let's say that my plus or minus 1 SD was this big. Okay? Now, if I throw away the outliers, what happens to my SD? It becomes smaller. Which one is correct? The green one. So if I keep the outliers in place and I use the blue approximation, am I going to capture too many, not enough, or too few? I'm going to capture too many because this is correct. Does that make sense, Dex? Right, but the problem is we don't have the green line. Yeah, okay. Okay, good. What are we on? 10? A large representative sample of Americans was studied by the Public Health Service in Haines 2. The percentage of respondents who were left-handed decreased steadily with age, from 10% at 20 years, 4% at 70. The data show that many people change from left-handed to right-handed as they get older. No. So I would imagine the graph would look something like this. Oh, so that's one thing I was going to point out. Do people change from left-handed to right-handed? Probably not. Do left-handed people die at a higher frequency than right-handed people? Probably not. But percentage-wise, it shouldn't matter, right? If 10% of the population is left-handed and a whole bunch of people die, we would expect half of those people that died, or not half, sorry, 10% of those people who died were left-handed. So what's really going on here? Are more and more people becoming left-handed? No. Selective breeding. No, that's not it either. Okay. Can anybody come up with what and we don't know for sure, but I'm pretty confident I know what's happening. Okay. What's that? The opposite, right? So this is the percentage of left-handed people. There are more left-handed people in the young ages, percentage-wise, than in the older ages. Well, this is the whole chart. The whole chart probably looks like this. So the question is asking about this one and this one. And we answered that question. It's false. Okay? But is there any reason why you would teach your kid to be left-handed? If you want them to be a baseball pitcher, that's a good reason. Volleyball, okay? But I think something else is going on. I think left-handedness is more culturally acceptable than it used to be. I think people don't force their kids to be right-handed as much as they used to. Right? 50 years ago, can you see parents saying, I'm going to tie your left hand to your back and you will learn to write right-handed? Well, so like can openers, uh, not ballpoint pens, but fountain pens. Um, it it's way easier now to be left-handed than it used to be. So I think parents have stopped making their kids be right-handed. Can you see 50 years ago a teacher not allowing a kid to write with their left hand? Would that happen today? No, we don't care. We have progressed beyond right-handedness. So my guess is these people over here, there were actually more of them born left-handed, but society forced them into being right-handed. No, this is a cross-sectional study. Okay, so right now we go out and we ask everybody. Percentage-wise, the older people don't have as many left-handed people as the youngers, and that is because every year we loosen our cultural standards, stigmas, I guess, on left-handedness. Yeah, the answer's false. We went way beyond the answer. Okay, so can a cross-sectional study say people are changing their minds as they get older? No, that would have to be a longitudinal study. Okay, age 5, are you right or left-handed? Age 6, age 7. Oh, we get to 55 and now you're answering left-handed. That doesn't make any sense. That's not what's going on. But culturally, we're more accepting of left-handed people than we used to be. In fact, some people might think it's cool to be left-handed now, and they encourage that. All right. Are you left-handed? I I take back that statement. It's not true. Okay, 13. To measure the effect of exercise on the risk of heart disease, investigators compared the incidence of this disease for two large groups of London Transport Authority busmen, drivers, and conductors. The conductors got a lot more exercise as they walked around all day collecting fares. Do you know what a conductor is? They take your tickets. They walk up and down the train all day long, tickets, 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 tickets. What does the driver do? They sit there on the train and they push go, stop, go, stop. And then they ring the bell. And then when you're not standing where you're supposed to be, they speak in the mic and yell at you. Okay, so when we look at this information, the age distributions for the two groups were very similar. So when we look at the age of the conductors, their average, their standard deviation, and the age of the drivers, their average and their standard deviation, they look the same. So that's good. We have two groups that look to be the same. The incidence of heart disease was substantially lower among the conductors, and the investigators concluded that exercise prevented heart disease. Does anybody want to poke holes into that theory? What's wrong with it? Okay, is it an experiment? No, it's an observational study, so that's a problem. Okay, is it controlled? Well, kind of. We have non-exercising people and exercising people. Okay, and they have had to work there for a certain amount of time. And was it randomized? No. And that's the big problem. What's the problem with not having this randomized? So I talked to Bailey. Okay, you want to work for the London Transport Authority. Would you like to be a conductor or a driver? She would pick conductor. Okay. Now, um, why would somebody pick driver over conductor? Okay, that's that's a variable I wouldn't have thought of. But maybe they don't like to walk. They prefer to sit down. Okay? Or what if they have heart disease? Which one are they going to pick? Being a driver. So would that explain why more drivers had heart disease? Yes. Now, do we think exercise helps with heart disease? Yes, we do. But this is not an experiment, and so we can't really say, as the people in the study did, yes, exercise helps, because the people put themselves in their own category, and we highly suspect that drivers are categorically different than conductors. Conductors will probably like exercise, right? And they're probably already more healthy. And the drivers are probably the opposite. Okay, so A, what does it matter? Other investigators were skeptical. They went back and found that London Transport Authority had issued uniforms to drivers and conductors at the time of hire. A record had been kept of the sizes. Okay, so A, why does it matter that the age distribution of the two groups were similar? We don't want to compare apples to oranges, right? We want to compare apples to apples, which is a terrible game, by the way. There is no point. Yeah, but when I play, the your choice of pick is not held to any sort of standard. You can pick whatever you want. Anyway, there's no strategy. But when I play, I purposefully pick the ones that don't fit my hate that game. I I don't like it because I can't win. That's the problem. I can't use my brain to win. So okay. So my whole point when I play that game is to ruin it, and sometimes I win by ruining it. Okay. B. Why does it matter that all the subjects had been at the job for 10 years or more? So their health results are not the result of some previous employment, right? We want the conductors walking up and down the train for 10 years. We want the drivers to sit in the chair for at least 10 years. Because if you just got hired, has your job affected your health? No. Okay. C, why did the first group of investigators compare the conductors to drivers, not to London Transport Authority executive staff? Any idea? Well, conductors and drivers probably work the same hours, and they have very well-defined jobs. What do the executive staff do? Some of them probably run around a lot. Some of them probably sit around a lot. Right? It's less controlled. Okay, and D, why might the second group of investigators have been skeptical? It wasn't randomized. Okay, and if you were in the study, what would you do with the sizes of the uniforms? This is terrible. What would you expect to see? Drivers had bigger uniforms than conductors. Okay, and that would probably nullify your whole plan of using this study, because people who weigh more tend to have more heart problems.